Okay, let's consider this function here. F of x is equal to x squared. Okay, now I used first principles earlier, and I found that f dashed of x was equal to 2x. Okay, now what this means is that this right here is the gradient function. Now it's really important that we understand what exactly that means. What does that mean that f dashed of x is equal to 2x is the gradient function? Well, we know what this word gradient means. It's like the slope. Okay? Now this, by having a gradient function, I've got a variable in here, x. It means that I can find the slope at any given value of x. Okay? So let's have a look. Let me do a rough sketch. Okay, put some arrows here. These are your x and y axis. Okay, if I've got this function x squared, it should look something like this. Okay, that's a pretty rough sketch of it, but it looks something like this. F of x is equal to x squared. Now, what if I said to you, what is the gradient right here? Or what is the gradient? So if we're trying to find the gradient right here, then it's kind of that. What is the gradient over here? Well, it's that there. What is the gradient at this point? It's this. Okay, so I can actually use this gradient function to help me find the gradients at these different points. So for example, let's find the gradient at this point. Let's say on the x-axis that's 1. So I want to know what is the gradient. What is the gradient when x equals 1? Okay, for this function, f of x equals x squared. Well, I just find my f dashed of x. I know that my gradient function is 2x, so then I just find f dashed of 1. Well, f dashed of 1 is 2 times 1, which equals 2. So right here, I'm saying that my gradient is 2. Okay, what about down here? Well, I could predict from here what I think my gradient is. It's not steep positively, it's not steep negatively. What is my gradient here? Okay, hopefully you have a bit of an idea, but let's work it out using the gradient function. Again, use my gradient function, f of x is equal to 2x. I want to find the gradient at f dashed of 0. Okay, that's this point right here. When x is equal to 0, what is my gradient? Well, it's 2 times 0. It equals 0. So right here at this point, okay, here my gradient equals 0. And we can kind of tell that it's neither negative or positive, okay? It's actually that turning point. Whenever we have a turning point, we have a gradient equal to 0. Okay, let me just erase this one here. Let me just do one more for you. Okay, what about this point here? Okay, what is my gradient here? And hopefully, here I've got a 0 gradient, here I've got a positive 2 gradient. Here we should get a negative 2 gradient. Let's say this here is negative 2. So I want to find my f dashed of negative 2. Well, that's 2. Remember that f dashed of x, the gradient function, was equal to 2x. So f dashed of negative 2 is 2 times negative 2, and it equals negative 4. And that fits what we've got here. Okay, if this were even more accurate, this is steeper and it's negative. Okay, so here the gradient is equal to negative 4. Okay, so I've used the gradient function, this here, to find the gradient at different points on my original function. Right? And that is one of the main reasons why we find the gradient function, because I want to find the rates of change at different points on my graph. Okay?